again, I've gotten here a question that actually touches on a practical that was done, and it is actually able to borrow some knowledge from this topic called enthalpy changes in form. We are trying to imagine, for example, I've been given a beaker and they have placed here, for example, 50 centimeters cubic of concentrated sulfuric acid, and they add some solid, let's say magnesium solid. Obviously the magnesium will react with the concentrated sulfuric acid to give us two products, and those are magnesium sulfate, sulfur dioxide, and water. Why? Because the acid is concentrated. So we shall have magnesium reacting with sulfuric acid in this case. What you need to note is that this reaction is actually going to be exothermic. A large amount of heat gets given to the surrounding. A large amount of heat gets given to the surrounding. That tells you that the reaction is exothermic. So in case I dip here a thermometer, and this is the solution, and the two are reacting, if the two form a system, the metal and the acid form a system, that system will give heat to the surrounding. And when the system gives heat to the surrounding, a reading on the thermometer will actually rise. When a reading on the thermometer rises, that means whatever has been placed here, now the reactants forming a system end up giving heat to the environment. And that makes it possible for the reading on the thermometer to actually rise, to show that the reaction is exothermic. To show that the reaction is exothermic. To show that the reaction is exothermic. So it is actually very possible for you to actually tell whether the reaction is endothermic or exothermic. Tell whether the reaction is endothermic or exothermic. Endothermic or exothermic. So for example, I'm supposed to actually realize that if I want to get the enthalpy change for the reaction, the enthalpy change for the reaction, or the heat change for the reaction, we will always say the mass of the solvent that has absorbed the heat multiplied by the specific heat capacity multiplied by the change in temperature. Good. How do I get the mass? You can be told that the density of the acid, or the density of the solution, is 1 gram per centimeter cubic. Then you have used 50 centimeters cubic. So we have used volume as 50 centimeters cubic. Then what do we expect here? We are going to actually say density is equals to mass over volume, because we want the mass, and the volume and the density will give us the mass. So how do I get the mass? So I'll say times V times V. So this and this will disappear. So mass is equals to density times volume. So that means, how do I get the mass? I'll take the density 1 gram per centimeter cubic multiplied by the volume 50 centimeters cubic. So this and this will disappear. So what do I have? 50 grams. Good. So I'm going to say 50 grams as the mass multiplied by the specific heat capacity, which is actually 4.2 joules per gram per Kelvin, multiplied by the change in temperature. Let me actually come back to the thermometer that was actually dipped into the solution. Let me assume the original temperature was actually 35 degrees Celsius, and maybe the temperature might have actually ended up rising to, let's say, 50 or 60 to be precise, or even 55. So you're going to say from 35 to 55. So the change, delta T, the change in temperature. So I'm going to say final temperature reading on the thermometer minus initial temperature reading on the thermometer. So I'll say 55. So delta T is equals to 55 minus 35. So the change in temperature is equals to 20 degrees Celsius. Good. Final reading of thermometer minus initial reading of thermometer. And when you get a thermometer in a practical lesson, you may not actually end up finding the thermometer having a 0 reading. Why? Because a thermometer will always take the room temperature. So that means it might read 20. So if you have been told to heat a compound to a particular temperature, please take 20 degrees Celsius as your initial reading. Don't expect to have actually the zero reading on the thermometer, because it will always take the temperature of the room. So it starts from 20, then going forward, you can be able to record the final temperature of the thermometer reading. So you are going to say times 20, the change in temperature. Don't change this into Kelvin. That one only gets done under a topic called gas laws in Form 3. So if you have 20 degrees Celsius, please take that one to be 20 Kelvin. Then you're gonna want to see. So Kelvin and Kelvin disappear, grams and grams will disappear. So what do we have at the end of the day? We are going to say 50 times 4.2 times 20. You can have 4200. Good. 4200 joules. Or if the temperature reading can have a difference of, let's say, 15 degrees Celsius, that gives us now the enthalpy change. So we can have maybe 35 up to 50. So that means from 35 to 50, we are going to have a delta T, or a change in temperature, as 15 degrees Celsius. Good. So I'll come here and say 50 grams, the same mass, multiplied by 4.2 joules per gram per Kelvin, multiplied by 15 Kelvin. So what do I get? Yes, in case I'm using 15 degrees Celsius, the change in temperature. So I'll have 50